The final exam review. Number 1, we've got a bunch of integrals to do. So if I want to integrate cosine to the 5th x sine x dx, the first thing I might notice is that cosine and sine are derivatives of each other, which means typically indicates a u substitution. So I'm going to let u be cosine x, which means that du dx is negative sine x. And I'm going to solve for the dx here. So dx is du over negative sine x. And then I'm going to go back to my integral and I'm going to substitute in all my u's. So cosine to the 5th, that becomes u to the 5th. And then copy the sine x, and then replace the dx with du over negative sine x. And my signs cancel, but I do still have a negative sign. So then it's just a antiderivative of u to the 5th. So this becomes the negative from this negative sign down here. U to the 6th over 6 plus c. And then the last thing you have to do is plug your u back in. U was actually cosine x. So this is negative cosine to the 6th x over 6 plus c. All right, this next one, the integrand is a fraction, and the denominator factors, which tends to indicate to use the technique partial fractions. So before I even try to do integral stuff, I want to break that fraction up into 2 fractions with linear denominators. So I'm just going to over here, I'm not doing anything having to do with the integral. I'm just trying to break up this fraction. So we put a constant over one factor of the denominator plus a constant over the other factor, because x squared minus 1 factors to x plus 1, x minus 1. Then we multiply both sides of this equation by the common denominator, x plus 1, x minus 1, multiply both sides. Okay, so on the left, the entire denominator cancels and you get x plus 3. And on the right, with my a fraction, the x plus 1's cancel, and I'm left with a times x minus 1. And with my second fraction, with the b, the x minus 1's cancel, and I'm left with b times x plus 1. All right, now this equation is supposed to be true no matter what value of x you plug in. So I'm going to choose some x's strategically so that some stuff cancels. Like if I put in x equals 1, then this term is going to become a 0. So that whole term will drop out. So let's put in x equals 1 first. So I get 4 equals, this term drops out, and I get 2b. And then let's put in x equals negative 1, because that will make my b term drop out. So negative 1 plus 3 is 2, and negative 1 minus 1 is negative 2. So I get negative 2 equals negative 2a. Solve each of these, so I get b is 2, and a is negative 1. Now I can rewrite my integral as 2 separate fractions. So I'm going to do that down here. So my integral of x plus 3 over x squared minus 1 dx, I'm going to break this fraction up into the sum of these 2 fractions, where I'm going to replace a and b with the values I found. So this becomes a is negative 1, so I have the integral of negative 1 over x plus 1 dx, plus the integral of b is 2, so 2 over x minus 1 dx. And then these are fairly straightforward to integrate, because the integral of 1 over some stuff is the ln of the stuff, and you just have to be conscious of the chain rule. But in this case, my coefficients on the x's are both 1s, so I shouldn't have a problem. So this becomes negative ln of x plus 1 plus 2 ln x minus 1 plus c. All right, my next one, square root x times ln x. It's a product, but my two terms are not, one is not obviously a derivative of the other. Ln x and square root x are not related by a derivative, which means that u substitution is not necessarily going to work. So instead, I'm going to try by parts. So that means I have to choose something for u and for dv. So part of my integrand is going to be u, and the other part is going to be dv. You want to choose dv as the hardest thing that is still possible to integrate. So I would choose it to be ln x, except I don't know the antiderivative of ln x. So I'm going to choose u to be ln x because I know its derivative. And dv is going to be square root x dx, the rest of the integrand. Then I have to calculate du and v. So on this side with u's, I'm taking a derivative, and with v's, I'm taking an antiderivative. So du, the derivative of ln x, is 1 over x dx. And then v is the antiderivative of square root x. So that would be 2/3 x to the 3/2. All right, and then we just have to remember the formula for integrating by parts. The integral of u dv is equal to u times v minus the integral of v du. So u times v, that's u times v. So I have 2/3 x to the 3/2 ln x, that's u times v, minus the integral of v times du. So v is 2/3 x to the 3/2, du is 1 over x dx. I'm going to simplify that integrand a little bit. So this is an x in the denominator, this is x to the 3/2 in the numerator. I'm going to subtract the exponents to get x to the 1/2. So this is 2/3 x to the 1/2 dx. Okay, so then in my next step, I just have to do this last integral and I'll be done. So I have 2/3 x to the 3/2 ln x minus, the 2/3 is going to come outside the integral, 2/3 times, and then the integral of x to the 1/2 is 2/3 x to the 3/2 plus c. But 2/3 times 2/3, I'm going to rewrite that as 4/9. Okay, last one. I want to take this integral of 1 over x squared times the square root of 25 minus x squared. So when you see this sum or difference of perfect squares, that is a hint that you should be using a trig substitution. So if you remember, when it looks like a squared minus x squared somewhere in your integrand, that is a hint to use the trig substitution x equals a sine theta. So we're going to let x equal 5 sine theta, which means that dx, the derivative of 5 sine theta, would be 5 cosine theta d theta. And now I make my substitutions. So this becomes the integral of 1 over x squared is 25 sine squared theta. And then I have a square root of 25 minus x squared. So 25 minus x squared is 25 sine squared theta. And then times dx, which is 5 cosine theta d theta. So there's going to be a lot of simplifying here. This becomes the integral of 1 over 25 sine squared theta times the square root. And now I'm going to factor out a 25. So I have 1 minus sine squared theta under the square root times 5 cosine theta d theta. Now 1 minus sine squared is a trig identity. That is actually the same thing as cosine squared theta. So I'm going to rewrite this as 25 cosine squared theta times 5 cosine theta d theta. I'm going to take this square root now. That becomes 5 cosine theta, which is going to cancel with the 5 cosine theta in the numerator. So this is 5 cosine theta, cancels with that. So this becomes 1 over 25, oops, 25 sine squared theta d theta. Sorry, that d theta stayed. I didn't mean to cross it out. And 1 over sine squared, that's the same thing as cosecant squared. So I'm going to pull the 1 over 25 out of my integral. And 1 over sine squared is cosecant squared theta. And then you were given a hint earlier in the problem that we should remember that the integral of cosecant squared is negative cotangent. So that should be helpful. So my next line, I have 1 over 25 times negative cotangent theta plus c. So I'm done with the integrating. Now I just have to translate this back to the original x's. So I'm going to do that by remembering what theta is. So I have to go back to when I started my substitution. Here's how I defined theta. It was x was defined in terms of theta. I can go backwards and define theta in terms of x. So x was 5 sine theta. So I'm going to come down here and write that down. X was 5 sine theta. To solve this for theta, I would divide both sides by 5, so I get x over 5 equals sine theta, which is all I need for the moment. Okay, so the sine of theta is x over 5. So I'm going to draw a picture to represent this. So a right triangle. Here's theta. The sine of theta is x over 5, and in right triangle trigonometry, sine is opposite over hypotenuse. So this is x and this is 5, which leaves the second leg to be the square root of 25 minus x squared. And then what I'm looking for is the cotangent of theta. And the cotangent of theta in a right triangle is, well, let's see, tangent is opposite over adjacent, cotangent is its reciprocal, so adjacent over opposite. So you look at theta, pick the side adjacent divided by the side opposite, adjacent over opposite. So we're going to have the square root of 25 minus x squared over x. That's the cotangent of theta, and then the plus c.